Welcome to my channel, and I'm back with you once again with another video of Microsoft Flight Simulator. Nowadays I'm exploring the Airbus A310, which is the default plane for the Microsoft Flight Simulator, and in this regard I'm doing a series of videos so that I can cover all the information related to a flight for this plane into different videos so that it's easy for you to look for a specific information on my channel. This is going to be a complete tutorial for this plane, which you can say an A to Z tutorial for this plane, in which I will tell you how to start this plane from the cold and dark state, how to configure the MCDU, which is the multifunction control and display unit, how to fly the plane on autopilot, descent management, and ILS approach and landing. So it's going to be a very in-depth video, but I will just try to keep the information to the basic level, because all of my videos are for the beginners who are actually new to the flight simulation. So that's why I will be just touching the basic information, and I will be just taking you through the basic procedures. But anyhow, I will just make sure that after watching this video you are able to do a successful flight with this plane. This video is going to be a long one, so I will just try to cover each and everything, and I will not miss anything. But still, if you have any questions, the comment section is there for you, and you can ask me any questions related to this video. I will be doing a short flight from Qatar to Dubai, and it's afternoon, and it's going to be a short flight. So you can see I'm at the gate. So first of all, let's get some power in the plane. And if you go over here on the overhead panel, you will see these three buttons. This is for the batteries. So once you turn on the battery, there will be some life in the plane, and you can also do some ATC communication. Before I proceed further, I would just like to tell you that in this video I will not be using the ATC communication, because then it's a lot of disturbance during the video. But anyhow, if you want to do a flight with the ATC, you can also do that, or maybe I'll also upload another video in which I will tell you how to do a flight using ATC with this plane. So that's it. I also have a checklist, so I will just try to go through the checklist, and I will just make sure that we cover all the things related to the startup procedures. After this, you have to make sure that the wipers are off. If you go over here on the overhead panel, you will see these two knobs. So the wipers have got different speeds. You can always turn them on. If it's raining, then just make sure that the gear lever is down, as you can see over here. And if you're using any controller which has got a gear lever on it, just make sure it's also down over there. Otherwise you will have some issues during the flight. The throttle is in the idle position, and just make sure that the thrust levers are also deactivated. If you activate the thrust levers, these are the two thrust levers, they will be pulled all the way back. I will just try to show you like this. So just make sure the thrust levers are also deactivated and the thrust is in the idle position, especially also on your controller. Parking brakes are on. Now your flaps and slats, this is the control for the flaps and slats. They're all retracted. The speed brake is also retracted, and it's you can see it's fully retracted. And now the speed brake is armed. Just hold it and just pull it down, just to make sure that it's not even activated. Then the weather radar is off. If you go over here on the pedestal, you will see this the switch, which is for the weather radar. It's in the middle, which is the off position. And now I will just connect the external power. But before I connect the external power, I will take you to the electronic flight bag, which is the tab in the plane on the left hand side of the captain. And over here, if you click this option, you will see the ground services, and you can see the GPU is connected. If the GPU is not connected, then you will press this button and the GPU will be connected. Once the GPU is connected, you will see available coming on the external power button. Once you press it, now the plane has got full power. Before I proceed further, I would just like to tell you some basics about the power for the plane. Initially, when you start the plane, you turn on the batteries, as you have seen right now in this video. The batteries give some initial power to the plane, and then there is a ground power unit which actually provides power to the plane to turn on the AC and plus all the electronic systems, because once the plane is at the parking gate, the engines are off and there's no power source. So once all the ground services are complete, passengers are on board, and the plane is about to carry out a pushback, the external power is disconnected because obviously the GPU cannot remain with the plane for the rest of the flight. The plane then switches to the APU, which is an auxiliary power unit. It's a generator at the back of the plane, which provides not only power to the plane, electrical power and air conditioning as well, but also compressed air is generated by this generator, which helps the engines to start. So after the pushback, you start the engines, and then the power switches to the engines, and then you turn off the APU. So this is kind of a procedure that you have to do. So that's why I've connected the external power so that we have some power in the plane. Now just make sure that the oxygen is on. Just go over here on the overhead panel and you press this button, and you will now have oxygen in the plane. Now there is one test that you have to do. It is the annunciator test. If you look at over here, so just make sure all the lights are on, all the buttons are working, and the sound commands are also coming, and you can then just turn it off. So this is something you have to do before you proceed with the complete startup procedures, or you go with the pre-flight procedures. With this, now something that you really have to do is turn on the ADIRS. There are basically 3 knobs over here on the overhead panel. This is ADIRS 1, 2, and 3. ADIRS is Air Data Inertial Reference System. It is actually a system which provides GPS coordinates to the autopilot or to the flight management control and guidance system of the plane. So if the ADIRS is not on, the plane will not get the GPS coordinates, and it will not know what is the position of the plane, and obviously the plane will not follow the flight path. So for this, you have to turn on the ADIRS knobs. You have to turn them to nav. As you can see, nav is coming. So just turn all these 3 knobs to nav. ARS alignment has got 3 settings. If I go to the electronic flight bag, in the settings, you will see that it has got 3 settings: realistic, short, and instant. Realistic will take 7 to 8 minutes, short will take roughly 2 to 3 minutes, and instant, it's done instantly. For this video, I've kept it at instant, but if you want to have some realism, then you can go with the realistic. With this, what I can do is this, that before I go with the pre-flight procedures, I can go to the ground services, and I can also connect the jetway. And you will see that the jetway will be connected to the plane like this, and you can use the electronic flight bag to connect the jetway to the plane. That's it, and you heard this sound because the forward door is now open. With this, you can also open different doors. As you can see, forward cargo, aft cargo, bulk cargo, and different doors, you can do them. But if you are carrying some ground services, you'll use them. But in this video, I will not be using any ground services. So that's why I'm not opening doors. But if you call for a ground service, any door which is relevant to that ground services will open. Now, before I proceed further, what we have to do is this: we have to make a flight plan. And for the flight plan, I will be using Simbrief. So I'll just take you to Simbrief, and I will tell you how to make a flight plan over there. So this is the interface for the Simbrief, and I've been using it for a very long time. It's a very nice resource available. You can make your account for free. There is only one thing that you have to do is this: get a subscription for Navigraph, because you have to update the ARAC cycle. ARAC actually stands for Aeronautical Information Regulation and Control. This is actually a database which has all the information of the airways, the waypoints, the departure procedures, and the arrival procedures for different airports. If the ARAC cycle is not updated in the Simbrief, you will not be able to do a complete flight plan in the plane. There might be a disconnect because the Microsoft Flight Simulator's ARAC cycle is always updated. And if your ARAC cycle is not updated over here in the Simbrief, then you might face an issue that you get an airway or a waypoint or a departure procedure or an arrival procedure which is not there in the Microsoft Flight Simulator. So that's why you can have one-time subscription. You can update the ARAC cycle, which can remain valid for 6 months or 1 year maybe. In the aviation, there are not so many changes going on. It's I think, if I'm not wrong, it's for €9. Or maybe I think 9.8 or 9.9. It's not on the top of our mind. But you can get that subscription one time, update the ARAC cycle maybe for the next 6 months. You will not worry about the ARAC cycle. So if you look at this interface, first of all, you have to start entering the information. You have to enter the departure airport, which is OTHH. This is for Qatar, Hamad International Airport. And I will be going to OMDB, which is for Dubai International Airport. It's a very short flight. And the aircraft type, it's A310-304. It comes over here like this, but in the Microsoft Flight Simulator, it comes as 310-300. And for the variant of airframe, just select iniBuilds A310 because the A310, which is available for the Microsoft Flight Simulator, it's from iniBuilds. Then you have to enter the cost index. It's actually a number which determines the fuel burning rate of the plane. The higher the number, more fuel is burned. The plane goes at a higher speed. Smaller the number, the plane goes at a slower speed. And the range increases, less fuel is burned. For this video, I'll use 40, but you can also use 50, 60, or 70 or 80. But just remember, the higher the number, the speed increases once the plane is cruising. The smaller the number, the plane goes at a slower speed. That's it. It's actually a number for the airlines. They use it. But for your flight simulation, you can use any number as per your convenience. Then you have some information of the ARAC cycle. Because my ARAC cycle is updated, you can see it's valid from 16th of May 2024 to 12th of June 2024. Units are in kilograms, but if you want to change it to pounds, you can use that. Now, you can see the total flight time is coming 1 hour and 10 minutes. Departure runway, I will be using 16 lift. You can see there are 2 runways for the Hamad International Airport. And this is the runway 16 left, so I will be just departing from this runway. And then I will take this route. Arrival runway, I will be using 12 right for the arrival. Right now, the default runway that's selected is 30 left. So I will use 12 right, and you will see the flight plan will also change over here. And plus the arrival procedure is also there. Altitude will be 28,000 feet. Because it's a short flight, I cannot climb up to 35,000 or 38,000. Passengers, full. And freight, set it to auto. And that's it. This is the information that you need to enter over here in this interface. And you will get the flight plan. On this side of the flight plan, you will also see many other options coming. You can always change it, but just use the flight plan that you get. Now, this flight plan has got 4 different parts on it. The departure procedure, the arrival procedure, and the airways and the waypoints. So now I will just give you a little bit of introduction of the departure procedure, the arrival procedure, and the airways and the waypoints, how you read it. When you are flying out of an airport, you don't simply fly out of an airport. There's a certain procedure that you have to follow. This is known as the SID, Standard Instrument Departure. And this procedure contains different waypoints, and plus it has different speed and altitude constraints. Similarly, when the plane is arriving at an airport, it doesn't simply come and land. As you can see, this should have been a straight line, and the plane should have landed at 12 right. But there is a certain path that's coming. This is actually a part of the STAR, which is Standard Terminal Arrival, and it determines the arrival procedure. Also, it contains the speed and the altitude constraints. As I'll do the flight, you will see it in this video. So this is the SID, ALSE2M, and this is the STAR, VUT E3E. So just to bring one thing to your notice, if you look at this flight plan, the last waypoint is VUTEB, which is this, and then there is a star, arrival procedure. And all these waypoints, they are not coming over there in this flight plan because they are part of the star. Similarly, it's for the departure. Now, in between are your waypoints and airways. Anything coming in alphabet value is the waypoint. So LSIM, ITBUL, these are the waypoints. As you can see, these points are coming. And then if anything coming in alphanumeric value is an airway, L305, M677, these are all the airways. If you want to look at the airways, just come over here and click this button and you will see all the airways. So after the departure, you will see this airway is being taken by the flight L305, which will take you from LSIM, and it will take you to ITBUL. So that's how you read it. You can see this airway has taken you over here, and then you take another airway which takes you to VUTEB, WUTEB, and then there is a arrival procedure. So these are the airways and the waypoints. Once I will enter this flight plan over there in the plane, you will further get a good idea of it. So once you make the flight plan, just go over here and press this button, generate flight, and the flight plan will be generated. And then just press this button, view PDF, and you will see the operational flight plan. Initially, if you are a beginner, this operational flight plan will look a bit confusing to you. So I will just try to make it simple, and I will just tell you which information to look for. And after this, you will be able to read this operational flight plan. And there is also a tutorial on the Simbrief site where you can just go and watch that tutorial, and it will tell you different parts of the operational flight plan and how to read it. So it's got all the information related to the arrival procedures, the departure procedures, the weather, and the wind information. So in this video, I will also tell you how to read it. So first of all, there are a few things that we have to take into consideration is the fuel and the zero fuel weight. So we have to enter this information over there in the plane. So coming back to the plane, I will just go to this option, weight and balance. As you can see, mass and balance, it's coming. Passengers, just set them to maximum because this is the amount of passengers that we will be carrying as per the operational flight plan. Now, if you look at this part of the operational flight plan, you will see planned fuel is coming. And the block fuel, the total fuel that you will be carrying will be 8,577 kilograms or 8.6 tons. So I will just enter 8.6 tons over here. Now you have to set the cargo. It's a tricky thing. And there are two things that you can do: either match the gross weight or the zero fuel weight with the weight given in the operational flight plan. So if you look at this part of the operational flight plan, it has got two readings coming. One is the maximum, another one is the estimated. Maximum is the maximum that this plane can carry, and estimated is as per the operational flight plan that we have made. This is the takeoff weight, 113 kilograms, 13,000 kilograms or 113 tons. Then you have the landing weight, because the plane burns the fuel, so at the landing the weight will reduce. And this is the zero fuel weight, which is actually the weight of the passengers and the cargo, but without the fuel. So it's 105.5 tons. So I will just match this number with that number, 105. So if I increase the cargo, you will see the zero fuel weight will also increase. So let's keep it at 105 tons. That's it. Now, your gross weight is 113 tons. And you can see it's 113, but it's 0.668. And over here it's 0.9. So maybe I can just reduce it because then it will impact the fuel. I think it's better because, it's not that accurate. But anyhow, you just try to get close as much as possible. Once you press apply, you will get the center of gravity as per the load in the plane, and you will get the trim settings for the pitch, whether to pitch up or down during the takeoff, the nose of the plane. So as it's slightly towards the forward, that's why you pitch up a nose by 1.1. This is also one of the settings that I will do once I will be configuring the plane for the takeoff. Now with this, I have to configure the MCDU. Now it's giving you this message, Align IRS, which is Align Inertial Reference System. You have to actually enter the GPS coordinates over here. That's why this issue is coming. I can get rid of it. Now the plane model is coming with the engine and the air rack cycle for the Microsoft Flight Simulator. Obviously it's coming. Now if you go to this option menu, you will see this option ACARS. And over here, you can enter the Simbrief username, and you can request for the flight plan from the Simbrief. Unfortunately, for the last 2 days, I'm unable to import the flight plan in the plane because of unknown reason. I don't know. I've been reading different forums, and people have this issue, but not most of them. But I have this issue. So in this video, I will not use this request Simbrief option. I will just configure the MCDU myself. In order to configure the MCDU, first of all, you have to go to this option Initialization, and you have to enter the departure and the arrival airport. So OTHH/OMDB. This is the format that you will be using. Just press this button. Now, interestingly, this is something new, which I'm observing over here in the MCDU. It automatically gets all the waypoints and the airways. So you can see these airways are coming: L305, L305 to Idbol, and then M6, as I've explained it to you before, M677 to Dixam, and then M677 to Vutub, and direct to OMDB. So it automatically is now picking up this flight plan. So you really don't have to worry about entering the flight plans and the airways in the MCDU. It automatically picks up for you. Just press this button, Insert, and that's it. Now you see this option, Align IRS. You just click this so that the MCDU reads the GPS coordinates, and now it says GPS primary. You can get rid of this message. Then the cost index, as I've entered it before, it's 40, so you have to enter the cost index over here. The cruising altitude will be 280, which is 28,000 feet. Nav accuracy upgrade. Now this message is coming. It means now the plane has got the GPS coordinates. Just simply enter 280, which is flight level 280 or 28,000 feet. Press this button. The cruising altitude will come, and you will have the temperature minus 56 degrees. Then flight ID, I always use AA123, and just enter it over here. Now you have to enter the cruise wind. Let's go to the operational flight plan and try to get the wind information at the cruising altitude. So if you go down, you will see top of climb, and you will get the wind information. As you can see, this column, it says wind. If you look at over here, 270 degrees, this is the heading of the wind, and 51 knots is the speed. So you have to enter it over here, 270/051. This is the format that you enter, 270/051, and that's it. Now you have given the wind at the cruising altitude. So for now, this is what you have to do in order to configure the MCDU. But now I will just proceed further with the pre-flight procedures, and then I will just come back to the MCDU to do further configurations. Now, as the fueling is complete, I have set the passengers, and the fueling is now complete. I can turn on the seatbelt signs. The smoking signs are also have to be turned on, and then you have to turn on the flight controller. So if you go over here on the overhead panel, you will see ground control. Just press this button, and I'm actually also looking at the checklist just in order to make sure that I don't miss any part. Okay. Now, what you have to do, you have to turn on the lights. So these are the controls for the lights of the plane: strobe, beacon, runway turn-off lights, so that the pilots can see left and right. So for now, you have to just make sure that all the lights are off except for the strobe. Just set it to auto, and nav and logo, just turn on the nav and logo. Now strobe is actually a white light which blinks throughout the flight. It turns on as soon as the plane takes off from the runway, and it is on till the time plane lands. So you can also turn it on, but right now if you turn it on, it will be blinking. So if you set it to auto, so as soon as the plane takes off, it will be on. Now for the nav and logo, just let me give you a little bit of introduction of the nav light. If I step out of the plane cockpit, you see at the wingtip there is a green light. So if any other plane is looking at this green light, it knows that the plane is moving towards the right side. Obviously in the morning the plane is clear, and they all can figure out that where this plane is heading, where's the nose of the plane. But especially in the night, it gives a very good indication that any other plane is looking at this plane and sees a green light, it means its nose is towards the right side. Similarly, on the left hand side, there is a red light which tells other planes that the plane is moving towards the left side. And then you have got these two bright lights at the tail of the plane. So if any other plane is looking at this light, it knows that it's looking at the plane from the back side. And then you have lights over here on the tail, which is your tail light. So now I've turned on the logo light, and I have turned on the nav light. With this, now I have to turn on the auto thrust system, which is known as the ATS. So if you look at the overhead panel, you will see these two controls for the ATS. Just simply turn them on. Then you have pitch trim. Pitch trim can only be activated if the IRS alignment is complete. For this, you have to turn on these three knobs for the IRS alignment, and plus, as you have seen it in the initialization phase, that I have pressed this button, align IRS. So once the alignment is complete, then you can turn on the pitch trim. If you're using an IRS alignment of 7 to 8 minutes, if you've kept it at realistic, then you will not be able to turn it on till the time alignment is done. As now I have done an instant alignment, so that's why I can turn on the pitch trim. And one more thing, I would just like to bring your notice to the FCU. This part of the plane is the FCU, which is the flight control unit. And over here, these two parts are known as the EFIS, or the Electronic Flight Instrument System. Right now you can see that FCU is not on. FCU turns on when you turn on the pitch trim. So it's a sequence. You get the IRS alignment, you can turn on the pitch trim. You turn on the pitch trim, you can interact with the FCU. So now as soon as I will turn on the pitch trim, you can see. And then you have yaw damper. Just turn all these three things on. Then I have to turn on the fuel pumps. As you can see, these controls are for the fuel pumps. They all say off. That's it. Then you have to turn on the window heat, and the probe heat, you have to turn it on. With this, you have to arm the emergency lights for the flight. And now just make sure that the APU is off, and you see this vertical line over here. I'll just show you. This APU bleed, it's off, and for the APU bleed, you see this vertical line over here. Just make sure it is like this, and the APU bleed is not on. With this, you see these controls for the air conditioning. You can change these controls as per the air conditioning required in the plane. Then over here, we have to set the brightness of the primary flight display and the navigation display. These are the two controls, so you can always move these knobs in order to change the brightness of the navigation display. This is the navigation display, and this is the primary flight display. Then over here, just make sure a flight director / FPV, the flight director is on. The switch is in the on position. You will see this crossbar. If I turn it off, you can see this, it's disappearing, but the flight director should be on for the autopilot and obviously for the ILS approach. Then on On this switch, you will have three settings: ILS, nav, and VOR. If you're doing a VOR navigation, which I will not be touching in this video, then this has to be turned to VOR. And if you're doing a GPS navigation, which we will be doing for this flight, this has to be in the nav mode. And once I will be near the Dubai International Airport runway, I will move it to ILS. Just make sure its position is on the nav. Now I have to set the altimeter. This is the altimeter of the plane, and we have to set the barometric pressure over here, because this plane determines the altitude of the plane as per the barometric pressure. So right now you can see the barometric pressure is coming in 2 units, MB and INHG. It's 1013 or 29.92 INHG. You have to adjust it, because then you will get the right reading on your altimeter. If you go to the flight plan and you scroll down, you will see this airport weather list. Now this is for the departure, and this is for the arrival. Now you can see over here QNH is coming 1007, so you have to adjust the altimeter to 1007. So once you will set 1007, now you will see you're getting the right reading, because the Hamad International Airport is 30-40 feet above the sea level. So that's why you're getting the correct information over here. You can also test for the landing gear error. So it's working fine. And just make sure that the rudder settings trim is actually set to 0. The rudder is actually at the tail of the plane, which moves the nose towards the left or right, a little bit of adjustment. If the wind is blowing from the right side, the nose is turned towards the left side in order to keep the plane straight. So if, see, it's more towards left, I'm setting the rudder. So you can always press this button in order to have readings 000 over here. That's it. Now I have to configure the MCDU, as all these procedures are complete. Now I will configure the MCDU and take you through all the procedures. So initialization you have done. Now you have to set the flight plan. So if you click this button, flight plan, you will see the flight plan, and it's coming. The departure airport is coming, and plus this is a level a point at which you will be reaching the top of climb, the cruising altitude. Then you have the airways L305, and it will take you to Astog, and then L305 to Burli. All the waypoints and the airways are coming. Now over here in this flight plan, you have to select the departure procedure. Just click OTHH, and it will ask you to enter the SID. Simply press this option, and then you can select the runway. I will be using runway 16 left for the departure, and over here SIDs are coming. In the operational flight plan, if you look at page 2, you will see this departure procedure ALSEM2M, it's coming, and you can see this departure coming over here. Click this and it says insert. Now you will insert it. Now you will see the heading of the runway is coming 156 degrees, and the time of departure 9:39. It's because 12:39 right now, and it's the UTC time. So in Qatar it will be right now 1:40. And UTC is 9:40. It's a 4 hours difference with Qatar. So you have these all. Now departure procedure, as you can see, initially the departure procedure was not coming, as now I've selected the departure procedure. The SID is coming, and all the waypoints this SID will follow, they are coming. And then after LSEM, which is the part of the departure procedure, you see then airways and waypoints coming. And then you have different flight levels and speeds coming over here. At this point, let me just give you a little bit of introduction how to read this. Now you can see speed is 250 and your altitude 3430. Then at this point 250 is the speed, and altitude should be more than 5,000 plus 5,000 and above this. Plus 500 500 feet. And this is actually 5,000, flight level 050, 5,000. Its minus is coming, which means you should be at or below 5,000 feet. Then at Go Blue, it's flight level 26,000, and so on and so forth. At over here at this point 28,000. This is the top of climb. I will be at 28,000 feet over here. Now another thing, or the last thing that we have to do, is select the arrival. So click star, and I will be selecting ILS 12 right. Now you have to select the transition and the arrival. Now in order to explain the arrival procedure and how you select the transition, I have to consult the airport charts. I'm using Navigraph, and I have access to the charts for the Dubai International Airport. So let's go over here and select the approach procedure. I will be using runway 12 right, and I can go for category 2 and 3 ILS runway. It's actually the precision. The most precise is category 3, then less is 2, and then 1. So there are different procedures that you have to follow. This plane is capable of carrying out the category 2 and a category 3 approach, and during the flight, during the approach, I will tell you what is the difference in the category 2 and 3. So what I'll do is this: I'll pin this chart over here, and I will just show you some interesting information over here. But before this, let's look at the star arrival, because I have to make you understand what the transition is. Because initially when I started this flight simulation, I didn't know how to get the transition. Transition is very simple. Now this is a very good example of understanding the transition. As you can see, that this is the arrival procedure. So now you're arriving at an airport. So before the approach, there are two procedures that you can take. Either you can go over here, we follow VUTEB 3B or 3E, and no matter what the option you select, you are coming to this point, re-rack. And if you look at the approach plate, re-rack is the initial approach fix, IAF, from where you start the approach, and then you come to this point, DB657, which is the final approach, and from here, then you will follow this glide slope in order to land at the runway. So that's why this is the transition. So in some cases, you can have multiple transitions. Always look at the approach plate. The starting point is your transition, or look at the star and see if different paths are converging at a single point, then that is going to be a transition. Because, if you're coming from here or here, you're coming at this point, re-rec. So transition is re-rec, and VU3B, VUT3E, this is the one, and just press insert. Now this flight plan is there, and all the waypoints and all the procedures are there in the flight plan. You can just scroll through the flight plan in order to see whether you have the right flight plan or not. Move this knob to plan and just zoom out a bit, and then just go all the way to the top and just scroll through it. You will see your complete flight plan over here on the navigation display. And just make sure that it's a continuous line, it's not breaking, and you can see this procedure is as per the Simbrief. So this is the complete procedure, and this is the runway, and this line is actually your missed approach procedure, which I will not be doing right now, but I will be making another video in which I will tell you how to perform a missed approach procedure with this plane. Now move this back to map, and then you can zoom in. So this is for the flight planning. Now you have another option of secondary flight plan. You can copy the active flight plan, and this is a secondary flight plan. Secondary flight plan is actually a flight plan which you can use for engine failure, selecting an alternate airport. What I've seen about this plane is this, that if you try to change the secondary flight plan, this MCDU hangs. So that's why I don't touch this option. But you can see activate a secondary, it's coming. You can always make a secondary flight plan and activate it if you want to go with the secondary flight plan. But right now for this video, this is not my area of interest. It always messes up with MCDU. So I will just stick to this option. Then you have initialization B. So if you go to this option, initialization, you will see this arrow coming. It means it has another page. If you go to the next page, you will see that you have to enter some information, because every time when you see these square boxes, you have to enter information over here. It's mandatory. So the block fuel, let's see, the block fuel that you will be carrying, it will be 8.6 tons. So simply enter 8.6. This is the block fuel. Then the zero fuel weight in tons, not in kilograms. It's 105.006, so it's 105 tons. So that's it. And then you have the zero fuel weight center of gravity, which is coming over here, 25.5%. So this is going to be the format, 25.5. And that's it. Now you have entered the initialization B page, which actually helps the plane to determine how much fuel it has and how much for the reserves and everything. Yeah, so this calculation is coming over here. For the taxi, 0.4 tons will be used. And the trip time is coming, how much fuel you have, how much time you have. And anything for the reserves, 0.2 and 5.0% for the reserves. And that's it. Now, the last thing that you have to do is this. You have to get the takeoff performance because you have to set the flaps for the takeoff. Flaps not only provide lift to the plane and at slow speeds because the wingspan increases, but they also provide drag. So during the takeoff, you have to set the optimum level of the flap so that you get the lift, but there is no drag, so that the plane can easily climb. For this, electronic flight bag has the takeoff performance calculator. You can click this option, and then when you enter this information, you see these dashes coming. This is what you have to enter, and once you do that, you can calculate the takeoff performance. So first of all, you have to get the length of the runway. So if you look at the airport chart over here, this is the airport. You will see I will be using 16 lift. This is the runway, and its length is coming in feet and also the meters. It's 4850 meters. So click over here and 4850, and the heading is 156 if I'm not wrong. So it's there. And then the weight, the total weight of the plane, let's check it again. Gross weight is 113.6. So 113.6 tons. Flaps, I can change them, but as I've told you before, you try to have the optimum flaps. So I have 15 flaps and 15 slats. Now NTIs, engine only, and air conditioning is on during the takeoff. So with this, you will have flex temperature, V1, VR, and V2. Flex is actually a temperature which is set by the takeoff performance calculator. It assumes that the outside temperature is really high as compared to the actual outside temperature, so that during the takeoff, the flight management computer and guidance system actually reduces the thrust of the plane, because if it's really hot and you are trying to take off at maximum thrust, the engines will be heated up, and it will reduce the age of the engines. So that's why the flex to temp is actually a method which gives you a higher temperature, and it helps to have reduced thrust on the takeoff, because you have got a very long runway, so no need to go with the maximum thrust. V1 and VR is the speed, and V2 also is the speed. V1 is actually a speed at which or before which you can decide to abort the takeoff, but after this speed you have to take off, which is the VR speed. And at VR you have to rotate, and then after taking off you have to reach to the speed V2, 165 knots, at which the plane can still fly if one engine fails. So 59, just remember these numbers and you have to enter it over here. So if you go over here, you will see this button flexed to, and simply take this temperature to 59. That's it. And over here, you have to enter 138. 138. And for V2, it says FCU, Flight Control Unit. So you have to come over here and enter 165. That's it. Now after setting the V2, I also have to set the altitude. If I look at the standard instrument departure, you will see there are some altitude constraints. Now this is the SID, and you can see I can follow the flight path that this plane will be taking throughout this flight. Over here at this point, KASIS, I should be below 5,000, at or below 5,000, because there is a line coming on top of 5,000. Then at this point, LSIM, flight level 210 is coming, but it says by ATC only. So these altitudes will actually be given to you by the ATC. As I'm not using ATC, and that's why I will just try to follow these constraints. So just right after the takeoff, I will set the altitude to 5,000. Then after this point, I will set it to 21,000. And then after this point, I will climb up to 28,000. So over here, I will just bring my cursor over here. Once I see this up arrow, I will press it, and the units will now change in thousands. And if I do it again, it will change in hundreds. So keep it in thousands and just reduce it to 5,000. Then you have to select the heading of the runway. It's 156. Now, why I'm selecting this heading? Because in this video, I will be using this option profile mode and nav mode. And once I will turn on the autopilot, the plane will actually follow not only the flight path because of the navigation option on, but also the vertical path, the altitude to which the plane will be climbing, the speed of the plane, and plus the vertical path, this vertical speed of the plane. So this will be controlled by the profile. And obviously, during the takeoff and during the flight, I will explain how these features work. But in some cases, or if you're communicating with the ATC might give you a heading. If you're using VRAM, then instead of flying in the nav mode, you fly in the heading mode. And in this video, I will not tell you how to, or maybe I can just give you a little bit of introduction how to fly in the heading mode. But for this video, I will stick to nav. Now you have configured the FCU and everything is now done. It's time to lock the cockpit doors and start the APU. So if you go over here on the overhead panel, you will see cockpit door switch coming. If you move it below, the cockpit door will be locked. Now with this, I will be starting the auxiliary power unit, APU. You will see the switch. It says on. Just turn it on and press this button, start. And then you can see over here, if I select this option, APU, you will see the APU information coming. And as now I'm ready to start the flight, so I can go over here to ground services and disconnect the jetway. Now the jetway will be disconnected from the plane. And if I just go back over here and press this option door, we'll see the door will be closed, or otherwise I can close the door myself. Now you can see the door is automatically closed. So just make sure all the doors are closed. Let's go back to APU. It will take some time, and then you will see the N percentage, the rotation will increase, and plus the exhaust gas temperature, EGT, will also come. And then you will see that the voltage will also be displayed once the APU is available. This is actually the ECAM on the right side, and on the left side, this is electronic centralized aircraft monitoring screens, left and right, ECAM. During the flight, you really have to keep an eye on the ECAM, especially on the left one, because all the memos and all the alerts are coming over here. Now you can see the APU is now running, and soon you will have a voltage coming in from the APU. And then once you have the APU available, you can disconnect the external power because it's no longer required, as the plane is now generating its own power. Now you can see the voltage has started to come. And on the memo, you will also see APU running, coming on the ECAM, and it also says available. You can see on the switch, it's coming as available. Now with this, just turn on the APU bleed, and you will see this horizontal line over here. Now the APU bleed is also available, which is a compressed air, and it will be used to turn on the engines. With this, I can disconnect the external power, and you can also disconnect the GPU. Now, before the pushback, just make sure that you do few checks. Check if the seatbelt signs are on, and you have set the speed. You have selected the nav and the profile mode for the navigation, for the horizontal and for the vertical navigation. And the altimeters are also set. There is one thing I just would like to tell you. Right now you can see that when I was making changes over here, there are 3 altimeters. This is the second one and the third one over here on the first officer or the co-pilot side. If you go to the setting, you can basically link instruments. You can turn them off. If I turn them off, then I have to adjust all the 3 altimeters. And if I keep it on, I just only make changes to one altimeter and it will be changed throughout the altimeters. So just make sure you have set the altimeter, and the brake and anti-skid is also on. Just make sure the switch is in the up position and the doors are closed as we have seen before. And make sure that the beacon is on. Beacon is actually a light at the bottom and the top of the plane, blinking red light, as you can see it over here, and at the bottom, which actually tells the ground staff that now you're going to start the engine so that they can clear the area around the plane. That's it. Now it's time to call for the pushback. I can release the parking brake. Just simply click this. Parking brakes will be released. And interestingly, this plane has got a built-in pushback feature. So you can use this. Just press this arrow for the back and you will see the takeoff, so pushback tug will come and will start the pushback, as you can see it over here. So now if you look at the navigation display, you will be taxing all the way to this point. So for this, the nose of the plane should be pointing towards the right side, or during the pushback you have to turn actually left in order to move the nose towards the right side. So I will just wait for the right time to call for the pushback tug to steer to the left. And once the pushback is complete, then I will start the engines. Usually when I'm doing flights and I want to save time, I start the engines during the pushback in order to save some time. But for this video, I will just wait for the pushback to finish and then I will turn on the engines. That's how it's done. I think let's move it to the left. I was here in the month of February. I was going to Pakistan. I took Qatar Airways from Riyadh. It was a good flight, but the connection was really short. Now I can stop it. I think I got 40 minutes to get off from one plane and get to another one. It was really a tough time. So now as the pushback is complete, you can get the parking brakes on. And if you go out, you will see the tug is now disconnected. I should have been on this line, but anyhow, it's very difficult to have a precise alignment with this line in the Microsoft Flight Simulator. Now it's time to turn on the engines. So let's go to this overhead panel and engine selector. Just move it to A. Now you will see start 2 and start 1. These are basically the buttons for the engine. They say arm. First of all, you have to start the engine 2 on the engine on the right side. Just press this button and it says open. Now you will see these gauges moving, the exhaust gas temperature, the N1 and the N2. Just wait for the N2 to reach 20% and then you turn on this fuel control switch for engine 2. Now you can turn on the fuel control switch for engine 2. You can now see the engine 2 is running and engine 1 is now not running. Soon you will see that the right hand side of the plane will switch to engine power. Now it's done. This click, this shows that now the power is converted from APU into the engine. It's automatically done in this plane. Now it's time to turn on engine 1 as well. Just press this button. It says open and wait for this N2 for the engine 1 to reach 20, and then you can turn on the fuel control switch for engine 1. And here you go. That's it. And then you have the weather radar. Just turn it on. You have traffic avoidance system and collision avoidance system, TRA. Just set it to TRA. You will see traffic over here if there is any traffic. And now you can see the left hand side has also switched from APU to the engine. I can get the engine information over here on the eCam. If I go here, press this button engine, you will now see the engine information coming over here. Now APU is still running, parking brakes on, seatbelt signs on, no smoking sign on. APU is running, so we can turn off the APU because now we have power coming in from the engines. Just move this engine selector to continuous, and then you can turn off the APU bleed, and you can turn off the APU. It's no longer required. Turn on the anti-ice for the engine in case, because I'm not flying in the icing condition, but still to be on the safe side, just turn it on. Otherwise, if there are icing conditions and you feel that there will be icing, then you can turn it on. Otherwise, it's better to turn it on. Now just arm the speed brakes. Let me just go out and see. Speed brakes are actually flaps on the wings, and they help to reduce the speed during the flight as well, and during the landing once the plane is braking. Because right now during the takeoff I might decide to abort the takeoff, so for this I have to arm the speed brake. So once I activate the reverse thrust in order to stop the plane before the V1 speed, these speed brakes also come into action and the plane stops for the takeoff in case of a rejected takeoff. Just make sure that auto brake is set to max because for the aborted takeoff. And turn on the lights, runway turn off lights. Basically these are the lights on the left and then right hand side of the plane, which enables the pilots to see in the night. In the morning we turn them on so that the planes at the distance, if they are unable to look at your plane, these lights are so bright that planes at the distance can easily see your plane. Just turn it on. Wing light, just turn it on. Landing lights, set them to off, and nose set it to taxi, and before the takeoff I will set them to on. That's it. Now just make sure everything is good and do the flight control test. Just go over here and press this button, and on the eCam you will see the flight controls. Just move the yoke front and you can see the elevator working. This arrow is moving, and just pull it back as well and then move it towards the right. You can see the ailerons are also working, and plus the rudder, it's working. Now it's time to set the trim for the pitch for the takeoff. Just go over here on the weight and it says 1.1 up. So just come over here and it says right now, just make sure it's slightly 1 point ahead. That's it. Now they have set the trim. Now let's adjust my seat at the cockpit so that I get the best view. And that's it. So everything is now set. Just look at the overhead panel before you do anything. Just make sure all the lights are black because this is an indication In the cockpit, if any light is on, then you have to give it attention, and anything that's on, it is green, so it means everything is okay. There's no issue. So now I can release the parking brakes, and I can proceed with the taxi and then the takeoff. Just give a little bit of thrust, keep it at 30% N1. 33% is also good. And during the taxi, just remember this thing, that taxi line, or during the takeoff or during the landing, the line at the runway is just between these two buttons. This is a very good indication in this plane. I always keep the lines over here in the middle, and the plane is always on the line. I'll just show you if it works right now. If I keep it over here, and if I go out, you will see the nose is almost on the line. So just keep it over here in the middle, okay? It's very hot nowadays. Summers have started. Even it's 42 degrees in Riyadh today. Yesterday it was also very hot. Now I'm just going to hold short of runway 16 lift. I'm going to apply the parking brakes, turn on the lights for the takeoff. Now, there are a few things before I proceed with the takeoff. I would just like to tell you that if you look at the private flight display, your speeds are coming for V1, V2, and VR. The speeds are coming, and as soon as I will give throttle, you will see that the flaps and the slat settings will also start to appear over here on the private flight display. You have to keep an eye, and I will tell you when to retract the slats and the flaps. Slats are actually at the front of the wing, and the flaps are at the back. So the speed brakes are on. I don't know why they are armed. Let me just disarm them. This thing happens in this plane. I don't know. I've seen it. Let me just do it again. Now they are. Okay. So this thing happens. If it happens, just have a look at it and just deactivate them. Because initially when I was flying this plane, I armed the speed brakes and they were active. I had lots of trouble during the takeoff. Okay. So these are the slats at the front, and the flaps are at the back. So I am not going to set the flaps and the slats by 2 notches. Just bring this lever down by 2 notches, or in your controller, just press it the button 2 times. And you have 15 slats and 15 flaps. That's it. Now you can see the slats are now extended, and you also have the flaps, which will provide you a lift during the takeoff. Now once I'm on the runway, I will just move the throttle in such a way that I get N1 to 50%, and then I will press this button, which is the auto throttle button, and then I will not touch the throttle. Then the autopilot will automatically adjust the throttle as per the settings that we have done for the takeoff. So now it's time to release the parking brakes and proceed with the takeoff. Just make sure there is no plane. It's going to be a rolling takeoff. I will not stop. And now I will just give throttle roughly to 50%. And I will press this button And now the autopilot will do the magic. You don't have to touch the throttle. Just keep an eye on the prime flight display, and as soon as you touch the VR speed, just rotate. Too much wind right now. It's getting difficult to keep the plane straight. You see this one coming. This is the point at which you rotate and rotate. You have a positive rate of climb. Just retract the gears. As you can see, the vertical speed is there. And now as you have crossed this F, you can just retract the flaps by 1 notch. The flaps will go up, but the slats will still be there. And as soon as you reach the S speed, which is the slats, you can also retract the slats. Now I can also retract the slats. And this is the green dot speed, which is the speed at which the plane can fly easily without any slats and flaps. And now I can increase the vertical speed. As you can see, it's coming almost 4,000 feet. And with this, I can activate the autopilot and let the autopilot do all the flying. So that's how you take off. Now, if I press this button, constraints, you will start seeing the constraints over here. 500 and above, this constraint is coming. Then over here, speed should not be more than 250 knots, and the plane should be at 5,000 or below, not above 5,000. So I'm using the profile mode. Actually, what's the advantage of using a profile mode is this, that you set your cruising altitude to 28,000 feet, you activate profile, and the plane should follow the constraints. But what I've seen is this, that this plane doesn't follow the constraints during the takeoff or during the landing. But during the takeoff, I always use profile mode, but during the descent, I use the level change or the vertical speed mode, which I will definitely explain it to you in this video. Now you can see the plane is actually following the flight path because nav is active, and it's not following the heading because heading is set to 156, and right now you can see the nav is on. Even if I change the heading, nothing will happen. But if I'm flying in the heading select mode, then the plane will go in that heading. So let's say if I set it to 140 and I press this button, heading, you can see it has started to move in that heading. And if I press nav again, it will start to follow this line. So this is a very small introduction of heading select and the nav mode. The difference between them, it's a lateral navigation. And now you can see the plane has leveled off at 5,000 feet. At 10,000 feet, I will turn off the lights and turn off the seatbelt signs. And plus, I also have to change this barometric pressure from the given one to the standard one at the transition altitude. If you look at the standard instrument departure chart, over here you can see transition altitude, it's coming as 13,000 feet. So at 13,000 feet, I'll just change it from the given one to the standard one. Just wait for the plane to cross this point, and then I can still further climb to 21,000 feet as I've shown you before. This is another constraint that I have. But remember this thing, just for this video, I'm demonstrating this thing to you. But if you're flying with ATC, obviously the ATC will be giving you different instructions based on the traffic in the area, and you will be getting different altitudes. But just for this video, I'm just telling you how you manage this. So keep the plane in the profile mode. As now I have crossed this point, I can bring my cursor over here. As soon as I see the down arrow, I can press this button, and then you will see the vertical speed will increase, and the plane will start to climb to 21,000 feet. So the autopilot for this plane, you might find it a bit complex if you are flying the Airbus A320 and other planes, Boeing 787, 737. But once you know the features and how they actually behave, it will be very easy for you to do a flight with this plane. Now, as the plane is crossing 10,000 feet, I can turn off the seatbelt signs and I can turn off the lights. I'll set nav to only nav. Logo will be off, but nav lights will be on. Wing light off, and the landing lights also off, and the taxi lights also off. you have turned off these lights, and you can also disarm the speed brakes. That's it. Now the plane is climbing to 21,000 feet. I would just like to tell you one more thing. If you look at this panel, you will see different modes that the thrust is in. Right now it's in the climb mode, and the thrust limit is also coming, and you can see it's set to auto. You can always change the thrust settings. You can either climb, cruise, MCT, or toga. Toga is actually full thrust for takeoff and go around, and this is MCT is for the flex to temp, and then flex to temp, and then you have climb and cruise. So right now the autopilot is automatically adjusting the thrust settings as per the flight plan. So right now it's in the climb mode. So if you look at over here on the private flight display, this part of the screen is known as the flight mode annunciator, or the FMA, and it gives you different information. Right now you can see profile thrust and profile climb. It means the autopilot is controlling the thrust, and it's in the profile mode, which means that the autopilot will be following all the constraints related to speed and related to altitude. So this will be controlled automatically. So right now you're neither controlling the vertical speed, the climb rate, or the speed of the plane. So that's why it's in the profile mode. Then there is an open mode. If you bring the plane in the flight level change mode or in the vertical speed mode, then it will be an open climb or open descent, and then this profile mode will just go away, and then you can see nav is coming, which means plane is in the nav mode. And if I just move it to the heading mode, you will see heading select mode is coming, and now the plane has started to turn towards the right side because it will follow the heading, and whatever the heading I will select over here, the plane will actually follow that heading. So let's press this nav button again, and then you will see nav coming. It means the plane is following the flight path. So if you deviate from the flight path anytime, you can press the nav button, and the plane will actually start to follow the nav mode. Okay. So on your screen you can see the navigation display 21,000 below. So by this point the plane will be or should be at 21,000 feet or below, and you can see this arrow coming, which is giving me an indication by this point, at this given rate of climb, the plane will be at 21,000 feet. And as soon as I will cross this point, I will again start to climb to 28,000 feet, which is my designated altitude for this flight. And as the plane has now crossed the flight level of 13,000 feet, which is the transition altitude, I can bring the cursor over here. As soon as I see the up arrow, I will press this button. Down arrow. Once you see the down arrow, you press this button and you see standard. Now you can see the altitude is now set across the three instruments, because I've set the settings over here in the electronic flight bag according to that. So that's why standard is coming on all the three altimeters. And during the descent, whatever the flight transition level is for the way, I will again change the standard barometric pressure to the given one. Now the plane is near this point, Elson. I can set the altitude to 28,000 feet, and as soon as I'll cross this point, I will again start to climb. Now I can press this button one more time. It actually pulls out the knob, and again the plane will start to climb. Now as the plane is climbing to 28,000 feet, there are a few things that we have to do for the landing, because we have got a very short time during the flight between the top of climb and the top of descent. It will be coming over here on the navigation display. By this point the plane will be at 28,000 feet, and over here I have to start the descent. So first of all, let's see to which altitude I should be descending. Just go over here on the charts and just look at the approach plate. So if you look at the approach plate, there are a few information that are coming. This is the frequency for the ATIs from where you get the weather information, and then you have the arrival frequency, approach frequency. Then you have the frequency for the localizer, which is used for the ILS. It's actually a ground-based device which emits radio signals, and the plane actually catches that and laterally aligns itself with the runway, and also follow the glide path, which is given over here. So the plane automatically follows this glide path and just touches the runway at the right point for the perfect landing. Now, as you can see, there are some headings, altitudes coming for the category 2. Decision height, this is DAH, which is decision altitude and height. So if your plane is capable of carrying out a category 2 ILS approach and it's ABC category, the decision altitude is 111 feet in barometric pressure terms, and in radio terms it's 100. Radio is actually a way a plane sends signals to the ground and just measures the height. It's ideal to use radio if you have a very nice and flat ground before the runway, but otherwise you will not have the correct reading. So that's why you always use the barometric pressure. So 111 and 100, and the runway elevation is 11. So I'll just go over here, enter 111, and this is what I'm entering in the takeoff performance page. So if you go here, 111, just enter 111, and it is actually, in terms of barometric pressure, 111, it's actually 100 feet above the runway because runway elevation is 11, so just add 100 to it. And for the height, in terms of radio, just set it to 100, because radio is actually emitting signals, and it just omits the 11 feet figure, because obviously it's reading the height from the ground. So that's why you set it over 100. And then you have the elevation for the landing. Just set it to 100 as well, because you cannot set it in units. So that's why you set it in hundreds. Set it to 100. Then there is another information that you have to enter. But before this, I would just like to tell you how to read this page. This is actually giving you different settings for the flaps and for the slats. You can have 20 slats and 20 flaps landing, which is over here. 20 and 20, 195. So this is the speed at which you can have 20 flaps and 20 slats. You can get this setting. I will be landing with full flaps and full slats, 30 slats and 40 flaps. That's why all the settings are as per that. And you can see the approach speed is coming, which is 136 knots. Okay, so go to this option, progress and descent forecast. You have to enter the wind information for Dubai International Airport, then at 20,000 feet, 15,000 feet, and 10,000 feet. But before this, just look at this navigation display, as this top of descent is near. So I will tell you to which altitude you will descend. If I look at this star, you will see that at this point, VUT EB, I should be below or at 10,000 feet. So once I'll start the descent, I will descend to 10,000 feet. So I can adjust the altitude over here so that I don't miss the top of descent. And I will just zoom in a bit over here so that as soon as I'm near this point, I will just activate the descent. Now for the wind information for the landing, just go to this page and you will see wind information, and you will see at 20,000 feet it's coming 268 degrees and 26 knots. This is the heading of the wind, and plus this is the speed of the wind. So just make sure that you have the settings for the wind so that you can enter it over there. So let's enter this information, the wind information over here. For the descent forecast, I actually have restarted the flight simulator because it crashed. Somehow for the last few months I'm facing this issue with the Microsoft Flight Simulator. It crashes. Even if I use the inbuilt Navigraph panel, it crashes. I've done many things, but still I have this issue. So if you find anything different, kindly ignore that. It will not impact your flight, because I have just started this flight again from the runway without doing the fuel calculation. So that's why you will have some issues, differences in the fuel and the gross weight, but you can just ignore it. So for the Dubai International Airport, you just enter the wind. It's 310 degrees, 310/015, or you can also enter 15. and it will pick up the wind information. And at different altitudes, you have to enter the same format, 200 for 20,000 / 268 degrees / 026. This is for flight level 200 or 20,000 feet. I think I can also start adjusting the altitude. So I've kept it at 10,000 because I have to be 10,000 below. Just wanted to show you something. Let me zoom in a bit. Now what I'll do is this. I'll just bring the cursor over here, and as soon as I see the down arrow, I will press it. And you see the descent has not started now. But as soon as the plane is near this point, you will see vertical deviation appearing on the screen and the plane will start to descend. So let's wait for it and enter the wind information. 150, which is flight level 150 or 15,000 feet. Wind is 280 degrees. And the speed is 014 knots. And then for flight level 10,000, it's 126 / 003. That's it. And I can bring up the flight plan again. Now I've also entered the flight information. Let's wait for the descent to start. If it doesn't start, then I can always press this button, level change, to start the descent. If it doesn't start, to descend in the profile mode. I think I can press it again just to make sure that it's active. So it didn't start. What I can do is this. I can press this button, level change, and then the plane will start to descend. Now you can see the vertical deviation is coming. This is happening to me for the second time. I recorded, this is the second recording that I'm doing. First I did for the RNAV approach, and now this for the ILS approach. Every time when I start recording, it doesn't start to descend automatically on the profile mode. But when I'm just like not recording, it happens. I don't know. So you can use the level change method, but in this method you have to actually control the speed yourself, because in the level change what happens is this, that the plane actually starts to give priority to the speed. As you can see, speed, it's coming. So the vertical speed is adjusted in such a way that whatever the speed is specified over here, the plane keeps on flying on the same speed. So if I, let's say, keep it at 330 knots, you can see the vertical speed is getting adjusted in such a way that the speed remains at 330. And if you switch to the vertical speed mode, then the priority is given to the vertical speed rather than the speed. It's better to descend using the level change or the vertical speed mode, because what I've observed is this, that in the profile mode, the plane actually controls the speed before this point, but it is not at 10,000 feet at this point. So that's why this you have to descend in the level change or the vertical speed mode. Turn on the seatbelt signs as now you have started the descent, and below 10,000 feet I will turn on the lights, and at the transition altitude I will adjust the altimeter. Now the transition altitude is flight level 150 or 15,000 feet, and the QNH at Dubai International Airport is 1008. So this is what we have to set at 15,000 feet. So now you can see this basically descent is a very aggressive descent, because I'm descending at a very high speed. So at this point I can bring the cursor over here, and I see the down button, I press it, and now I'm in the vertical speed mode, not in the flight level change mode. Now what's happening is this, that the autopilot will not go below 330 knots, But if I go for a very aggressive descent, it will disregard the speed. So that's why I have to adjust the vertical speed in such a way that the speed remains 330 knots. It doesn't increase more than this. It cannot go below than 330 knots, but it can go more than that, because if I have a steeper descent. Now you see this arc coming over here. Now the navigation display, this is a very good indicator which tells you that by which point you will be at the given altitude. So right now, as you can see, the descent was a very aggressive one. So that's why it was there. So I have good ground to cover. I can be at 10,000 feet by this point, so I can really adjust the vertical speed in such a way that the speed doesn't increase and it remains in a normal threshold. So let's say if I reduce the speed, will the speed reduce or not? You see, now the speed is reducing. So with this descent rate, yes, if I adjust the speed reduces. But if I go for a very high, let's say if I keep it at 6,000, you will see the speed will stop to reduce and it will start to increase. Just to show you, you see now the speed is not reducing and it will increase. 6,000 feet, it's a very high rate of descent. You can now see the speed has started to increase. So that's why the vertical speed doesn't give priority to the speed, rather to the vertical speed. So this is just for the demo. So now I can keep it at 1,000 feet. This was just to show you the difference between the level change and the vertical speed. So during the descent, all you have to do is just manage the altitude and the speeds as per the given constraints, and that's it. Now you can see the speed is reducing, and with this given rate of descent, by this point I will be there. And now let's change this as well, the altimeter, adjust it 1008. And just bring your cursor over here. When you see the up arrow, just press it, and then you can change the barometer pressure. That's it. To be on the safe side, I'll just turn on the lights, 11,000 feet, and turn on all the lights. That's it. Seatbelt signs are on, and everything is now good. Just one thing, just arm the speed brakes, because on the landing, I will actually use reverse thrust to stop the plane. Reverse thrust is actually a mechanism in which the engines just open, the sides of the engines open, and the thrust of the engine is reversed. And this is the reverse thrust lever. It's configured on my controller. If I move my thrust lever all the way back on the controller, the reverse thrust is activated. You can change it. You can also assign a key, go to the settings and look for reverse thrust, and you can assign it. As soon as you activate the reverse thrust, the speed brakes, as they're armed, they also are activated, and the plane stops, and then you have your brakes over here as well. They also come into action. You can have maximum, medium or low brakes. In order to activate the brakes, you have to move this gear lever in the middle, and then you can set the brakes either low, medium or max. So for this video, I will set it to medium. Now you can see that the plane has going to be stabilized at 10,000 feet, and still there is some ground to cover, so it's good. And then on the next point, I should be 7,000 or below. So after this point, I will start the descent further, and you can see the speed constraint is coming 230 knots, so I will further reduce the speed near this point. Now you can see altitude hold is coming. It means the plane is actually holding on to the altitude that's been entered over here. So it's in the altitude hold mode. But the nav mode is on, which is enabling the plane to fly on the flight path. Now let's look at the approach plate and get some information over here. At redirect initial approach fix, this point is coming. I should be at 3,000 feet. And I have to enter this ILS information, 109.5. This is the frequency of the localizer. So let's enter it over here, 109.5. And the heading of the runway is 119, so I will not only set it over here in case I have to fly in the heading mode instead of the nav mode, and I also have to set the heading over here, 119. Let's start reducing the speed, 230 knots. Now, if you look at this panel, you will see that at 245 knots, I can have slats by 15, or I can lower the flaps and slats by 1 notch. So my speed is going to be 230. So I can extend the slats because, during the descent, I need slats not only to provide lift to the plane, but also to reduce the speed. So it's a very good thing to do. As soon as you're given within the given threshold, just activate the slats so that you're able to maintain the speed during the descent, because then afterwards I will be going to 210 knots and 185 knots at different points. So let's look at the approach plate again. This is the point DB657 over here. This is the final approach fix, and after this the plane will actually follow this glide slope. So that's it. As a beginner, this is, I think, the information more than enough for you to read. Then otherwise, in your free time, you can further watch different videos or consult different material over the internet, how to read the approach plate. So the heading is given for the ILS DME. A DME is actually distance measuring equipment. It tells you the distance even from the runway. I will show it to you once I'm going to perform an ILS approach and landing. So 119 is the heading and 109.5 is the frequency of the localizer. Now let's adjust the altitude. Let's keep it at 7,000, because at the next point I should be 7,000 and below. And I can then activate profile mode and let the plane descend, because at this point re-reg I should be at 3,000 feet. But so in case if I was flying any other plane, Boeing 787 as well, it does it, and I think the A320neo also does it. If you're flying Phoenix or the fly-by-wire, if I set it to 3,000, it will just make sure at this point it's below 7,000, and it remains at 7,000, and then 6,000. It follows all these constraints that by eventually this point it is at 3,000 feet. But at this plane doesn't follow all these. So that's why I will keep the altitude to 7,000, but I will descend in the profile mode now instead of level change or vertical speed, because then in the profile mode the speed will automatically be adjusted by the plane. Now with this I can extend the slats and I can activate profile mode, and now the plane will start to descend to 7,000 feet, and you will see this arrow coming which will indicate that by which point I will be at 7,000 feet. So now the autopilot is automatically calculating it, and it will actually try to maintain such a vertical speed that my speed is not compromised. The speed remains 230 or as per the speed constraint, and it just descends. So you can see that before this point I will descend to 7,000 feet, but if the profile mode doesn't do this, then you have to change it to level change or vertical speed mode. And let's bring up also the takeoff and approach, the final approach. I can press this button in order to activate the final approach. The speed will automatically reduce to 127 knots. Let's see if it works. I should be in the profile mode to do that, so that's why now I'm using the profile mode, not the level change or the vertical speed mode, because then the speed will automatically be adjusted by the autopilot. I don't have to adjust it over here manually. This plane is capable of carrying a Category 3 approach and plus auto land as well. You can press this button as well, and it can perform a Category 3 approach and then auto land as well. I have done this 2 times, but it's not that accurate. So for this video, I will deactivate the autopilot Now I will not turn on this option to have a category 3 landing. So I'll just go with the category 2 because at category 3 you can set the minimums at 50 feet. Why you set the minimums? So the basic purpose of setting the minimums is to basically look at the runway. If the autopilot hasn't aligned the plane with the runway, or you're not going to touch the runway at the right point, then at any time you can perform a go around, or call it a missed approach. Because it's a precision approach, it's very precise, but obviously it also depends upon the GPS signals your plane is getting. And if it's not following the glide slope properly, or if it's not following the lateral alignment or the horizontal alignment, then obviously you have to do something about that. So that's why the minimum altitude, you look at the runway. If you align and you're going to touch the runway at the right point, there are 2 white and 2 red PAPI lights, which I will show you in this video. If it's like this, then you can proceed with the landing. Otherwise, you have to call it a missed approach, or then go around and come back. I will also try to do a video in which I will tell you how to perform a go around. So now the plane is at 7,000 feet. I can set the altitude to 6,000 and again press this button, and you can see the plane will again now start to descend, because at this point I should be at 6,000 feet or below. But now you can see in the profile mode, it's going to miss it, or it's going to, it's exactly at this point it will be at this altitude, 6,000 and below. And by this point the speed will be 200 knots. So let's wait, because I'm in the profile mode, so the plane should follow the speed constraint. Slightly missed it, but because I was a bit late also. This is actually the vertical deviation, which indicates how much off you are from the vertical path. If this diamond is below, it means you are higher than the vertical path. And if it is over here, this diamond is above, it means you're lower than the vertical path. So right now you can see I am exactly following the vertical path. Speed should reduce. Let's see if it happens. Yes, now you can see there's a new speed, and the thrust is now reducing, and the speed should reduce. Yes, it's reducing. At 210 knots I can have also 15 flaps. Right now only 15 slats I have, so I can now extend the flaps. Let's get the flaps and the slats, because then the speed reduces drastically rather than so slow. Now as I'm near the runway, I can also change the switch to ILS, and it will now start showing me ILS guides over here, the horizontal and the vertical. This will tell me my lateral alignment with the runway, and this will tell me whether I'm going to follow the vertical path or the descent. Right now, as I'm obviously I will be taking another left turn, and then I'll come back. So that's why this diamond is below, which is showing me that I'm higher than the descent profile, because at this point I should have been at 3,000 feet in order to intercept the glide slope. Because as I'm at 6,000 feet, I'm higher than the glide slope. That's why this diamond is here. But now as I will move away from the runway, this diamond will come in the middle. And at REREC 3,000 above, maybe I can start the descent at this point to 3,000 feet using the profile mode. So vertical deviation is good. I'm following the path, and plus now you can see this ILS indicator started to move up. So nothing to be really worried about. Now your DME is coming, basically distance measuring equipment, and the ILS localizer. It's telling you that how much distance you have to cover for the runway. Now you can see the speed has automatically started to reduce, because at this point my speed should have been at 185 knots. That's why it's reducing. And if you look at over here, at 195 I can have 20 slats and 20 flaps. So let's extend to 20 flaps and 20 slats. One more notch. I will not go for full flaps and slats right now, because this is activated with the landing gear. So if you go for the full flaps and slats right now without the landing gears down, you will hear the error. So that's why I'm not doing this. So I'm following the flight vertical path, which is good. There's deviation is not there, but as soon as I'll see the deviation, I will start the descent to 3,000 feet. Now the DME, as you can see, it's showing 22.9. As I'm moving away from the runway, that's why this number is increasing. But as soon as the plane will turn towards the runway at the heading of 119 degrees, then you will see this DME will start to decrease. Now you can see that the distance is 20.4 nautical miles from the runway. At this point, I can be above 3,000 and speed 185 knots. I'm really high than the descent profile. So what I can do is this: I can set the altitude to 3,000 and start the descent. Now the plane will actually go to 3,000 feet. This diamond was coming in the middle, but now it will start to go again up because I'm descending. And speed off 3,000 and above, and over here at this point DB657, I should be at 3,000 feet in order to intercept the glide slope. And as you can see by this arrow, that I will be 3,000 feet by this point, so it's okay. Now the plane will be leveling off at 3,000, just adjusting the course. Right now you can see the lateral alignment is not there, it's off. We are more towards the left side, but as soon as I'll press this button land in order to follow the glide path, the glide slope, this plane will actually align itself with the runway automatically. So this diamond will come in the middle. You will see some adjustments, but right now if I just proceed like this in this course, I will not be landing on 12 right, rather I'm going towards 12 left. Now the plane has leveled off at 3,000 feet. And the distance to runway is 11.4 nautical miles. Now you can see the speed has started to reduce. Automatically the approach phase is active. The speed is there. And the speed will further reduce to 126 knots. But right now it's not reducing because I don't have the full flaps and the slats. But as soon as I have the full flaps and slats, this will happen. And this speed reduced because I was already in the profile mode. So the plane has actually done it for me. Now, as soon as I've pressed the land button, you can see now the plane is aligning itself with the runway. And then as soon as this diamond is in the middle, you will see the vertical speed will also decrease, which means that the plane has now started its descent towards the runway. And right now, you can see localizer is locked and the plane is following the glide slope. Speed is controlled, and plus category 2 landing is going to happen. So if I turn on this button, you'll see category 3 coming. So it's going to be more accurate. And now at 6 DME, I can lower the gears and get the full flaps. Right now you can see the automatic descent has started because of the land option that I've pressed. All the lights are on, seatbelt signs are on, everything is good, speed brakes on, and the brakes is set to medium. But I'm not going to auto land. I will deactivate the autopilot at some point and I will try to land it myself. Right now you can see I'm properly lined with the runway. And this diamond is in the middle, so the plane is following the glide slope. Rather, I'll do it at 7 DME instead of 6. I can lower the gears down. So let's lower the gears. You will see the gear information on the eCam. And as soon as the gears are down, I can go with the full flaps and slats. And you can see now the speed has started to reduce further because this is my approach speed. So that's how the profile mode works once you are doing an ILS. So if you were in level change or altitude vertical speed mode, then you have to do everything yourself. So now the speed is at 138. I can reduce it. 126. And with this, I can deactivate the autopilot by pressing this button and just press it again to get rid of the error. And now I have the controls. All I have to do is this, just follow the glide slope. Let me just, yes, both the autopilots are now off because I used this button. You can see, just make sure they're off. Now it's up to category 1. So I've switched from category 3 to category 1. So I should have actually set the minimums as per the category 1. So as this diamond is going up, it means I have to pitch up a bit. And if this diamond goes down, I have to pitch down. So I'm a bit low right now. You can see 3 red lights and 1 white light. It means I'm low on altitude. I hope my landing is going to be a good one.
300. 200. 100.
Now 2 white and 2 red. This is a perfect glide slope. Yes.
40, 30, 20.
Just reduce the thrust, and with this I can activate the reverse thrust. Below 100 I will deactivate the reverse thrust. And now the auto brakes will come into action. The plane will stop. Okay, now I've applied the brakes. Sorry. Actually, it's a very precise movement on the thrust. It happens. So that's how you land this plane. And now I will just move towards the parking gate, and then I will tell you the procedure how to actually shut down the plane and park at the gate. With this, I can turn on the APU, because as soon as I park at the gates, you can see the brake fans are on now. It says delayed takeoff because now the brakes are heated up. So they will just cool down because the brake fans are on. So APU has to be turned on. And then with this, what you have to do is this, just retract the flaps and the slats. And disarm the speed brakes. Now move towards the gate. These gates look to be empty. So I will do that. You can see all the brakes are hot. So maybe at the next gate I can just park the plane. There's a plane coming. I can park it over here at A8. Is the APU available? Let's stop the plane over here. Apply the parking brakes. Parking brakes are active. APU, it says available. I can turn off the engines. Simply turn off the fuel control switch for the engine. Now the engine is off. You can turn off the seatbelt signs. You can turn off the lights. That's it. And you can set the engine start selector to off position. That's it. Now you can see all the controls are off, and let the brakes cool down. With this, now you can see external power is not available. Can I connect the external power? If I go over here, I can call for the GPU, and you can see now the external power is available. I can switch to external power, and then with this I can turn off the APU as well. Now the APU is off, and with this I can turn off the fuel pumps. Don't need them. That's it. Turn off the window heats, probe heats, and oxygen. The way you got it, just set the plane in such a way, the way you got it. ATS off, auto thrust, and what else? And just do this. And maybe you want to unlock the cockpit door. And that's it. So don't turn off the nav or the ADRS, or if you are going to store the plane, then you have to turn off the ADRS as well. So that's it. Now the plane has the power. Turn off the constraints, you don't need them. Maybe you can turn off the weather radar also. Oh, I didn't turn it on. The second instance of the simulator that I did, I didn't turn it on. The traffic avoidance system and the weather radar. So that's how you do a flight with this plane. And now you can do the refueling, all the calculations again, and then you can just go for another flight if you want to continue flying this plane. I hope this was a good video, and you will be able to do a flight with this plane. If you want to ask me any question, the comment section is there for you. I'm a bit lazy in answering the questions because I've got a busy schedule. I hardly get time to give you answers to your questions, but anyhow, I'll just try to manage. Thank you very much for staying with me. Have a nice day. Hope to see you soon.